story of a cup of water. I have loved chemistry since I was in high school, and now I work in chemistry. I would like to share with you an interesting story in the field of chemistry. Now, I will talk about the mole and Avogadro constant that appears in basic chemistry class. I think it depends on how well a person understands the mole and Avogadro constant that determines whether a person will like or dislike chemistry in the future. If you can understand the mole and Avogadro constant, you will be very interested in chemistry and you may want to study more. In chemistry textbooks, the explanation of the mole and Avogadro constant can be confusing and boring. I think that if textbooks introduced this in a more interesting and engaging way, we would be able to grasp it much more easily. I hope that by watching this video, you will be able to better understand the mole and Avogadro constant and how it is used. And you will be also surprised at huge number of the Avogadro constant. Okay, so firstly, what is the mole and Avogadro constant? Let's take a look. One mole equal 6.02 times 10 to the power of 23. There is a very big, very huge number, but it is difficult to understand. So let's replace it with a common example. We use names for sets of numbers in our daily lives. For example, if we cook 1 cup of rice, we don't say we cook 7,200 grains of rice. Everyone understands that it is easier and more convenient to put together such a large number under one name. That's why the Avogadro constant is the name for a large amount in the same way as a cup unit. The mole comes from the word molecule. Molecule is a neutral substance composed of 2 or more atoms. For example, oxygen, it is oxygen or water. The name of this video is a story of a cup of water. So let me use water as an example. Water is H2O in chemical formula. H2O is a molecule made up one oxygen atom and 2 hydrogen atoms. H2O has a molecular weight of 18. But how do we get that number? I will now explain that. The following presents the structure of the water. The atom is made of atomic nucleus and electrons. Atomic nucleus and electrons. The atomic nucleus consists of protons and neutrons. Protons and neutrons. The molecular weight are sum of protons and neutrons in the molecule. The electron is very light. Electron is very light than proton and neutron, so we can ignore it. Different atoms contain a different number of protons and neutrons. Protons and neutron both have a value of 1. In this case, oxygen atom contain 8 protons and 8 neutrons. 8 protons and 8 neutrons, giving us a total molecular of 16. A hydrogen atom contains 1 proton and no protons, giving us a molecular weight of 1. When we add together the total number of protons and neutrons in the 3 atoms of the H2O, molecular weight get to total of 18. I'll summarize the molecular weight of water. Proton and neutron both weight same. The electron is very light, so we can ignore it. Water molecule has 10 protons and 8 neutrons. So H2O has a molecular weight of 18. The molecular weight of water equal 18, number only. 1 mole of the water equal 18 gram, equal 6.02 times 10 to the power of 23 water molecules. In this, where the explanation in chemistry textbooks end. By the way, when we climb the big mountain or go to overseas trip, we may be impressed by the big size of the world and the scale of the natural world. However, we often give little thought to the opposite. The microscopic and molecular elements of the universe are just as impressive. Okay, so now we have an understanding of moles and Avogadro constant. How we can use this to better understand the world around us? Well, let's use something that affects us all and is one of the world's most pressing issues, the environment. It is difficult to realize how things we do in our everyday lives have an impact on something as vast as our planet. Using what we have learned, let's take a look at how a single glass of water could affect all the water in the ocean. After all, it is only a drop in the ocean, isn't it? Now, I would like to calculate how microscopic water molecules are. Let's compare a cup of water with the amount of water in the ocean. Collect all the ocean water from the entire global and put it in a large container. Of course, such experiment is very too large to carry out. It is impossible. But you can imagine in your head. In this case, the volume of ocean water equal 1.35 times 10 to the power of 21 liters. Let's continue the explanation. Examination all follows as follows. Take a 200 milliliter glass of water out of the container and mark each of the water molecules. Then return the marked water to the container and stir well to make its distribution evenly. And then take out another 200 milliliter glass of water. How many marked water molecules will we find? If you think you can figure this out, pause the video and give it a go. Then come back and check your answer. If all of this is going over your head, don't worry. Let's continue and work it out together. Next is a result. Here is a result. The answer can be obtained by the following formation. A number of marked molecules in the glass of water. Come back marked molecule number equal number of water molecule in a glass of water 200 milliliter times volume of the glass of water 0.2 liter divided by volume of sea water around the world. Very big, very huge number. Equal almost all people this volume of the sea water around the world is a very huge number. That's why answer is it's probably 0. Almost all people thinking. My case is same. But we calculate it and we get a surprising result. The answer is 991 particle water come back. This is nearly equal to 1,000 water molecules. So, from this we can see how even a single glass of water can theoretically have an effect on all of the water in the ocean. Now, image that our first glass of water was not water at all, but instead pollution. This drop in the ocean could actually spread throughout the sea, adding to any existing pollution already there. Where a single glass of polluted material would have a negligible effect on the ocean overall. When we think of all of the polluted material being added to the seas every day, it is easy to see how much damage is being caused. If you study chemistry, you can think more deeply, and you can decide your action in the future. It is very useful to study chemistry. Thank you for watching. Bye bye.